Hi, I'm smoking at the lab today by burning some resistors, so keep watching because there is a real reason for doing this. So I'm working on this power supply from a spectrum analyzer, and among other problems there are a couple of resistors that I've taken off it that are scorched beyond my ability to find the value. So the one on the left here starts with blue and appears to be brown, which doesn't make a lot of sense, so I'm guessing it's probably 680 ohms. And this one, of course, is scorched beyond any recognition at all. I've measured them with the multimeter, and the left-hand one here comes out at 600-ish, and the one on the right comes out at 1.1k, although it's a bit dodgy to measure, to be perfectly honest. It can kind of change value as you apply pressure, which will be a heat fracture problem on the probably where the leads go on. So I want to do some experiments where I heat up some resistors to find out which direction they alter their value. So do they go to a higher value? Do they go to a lower value? So I'm guessing this is probably a 680, something like that, and it has actually reduced in value from the heat. So I'm going to do some experiments. We'll find out if that's the case or whether they increase in value. Okay, so I started with a 1.2k resistor, and I'm just going to measure that and double check its value. So it's 1.195. Make a note of that somewhere. Yep, there we go. We've got a bit of smoke. The fan noise you can hear is my air extraction, which is why this is drifting off at a quite a steep angle. I think that'll probably do it. Okay, we've got a suitably crusty 1.2k resistor. I'll let that cool down a little bit. And I reckon the other one was going to be 620, didn't I? Or 680. I don't have a 620, but I might have a 680. Yeah, there we go. So this one should be a bit easier to get hot. Are we ready? Yes, we are. There we go. Oh yeah, look at it go. Oh, in fact, there we go. All off. Thank you. Yeah, I think we've demonstrated the point there. Great. Okay, so I'm just going to let's measure them again. Just zoom in a bit on that, I think, so we can see what's going on. Right, let's take the 1.2k then, and we will remeasure it, and it's now 1.11, so that's interesting. So I wasn't sure whether my resistance will be dropping or rising. I'd guessed at rising, so yeah, but this has actually lost about 10% of its value. Let's take a look at the charred 680 ohm. That's 6k. Wowzer. Interesting. Unfortunately, I mean, what does that tell me? It tells me that this resistor has no relationship to the value I'm reading, I think. So do I start off and hope that he was a 1.2k? If we assume that these two circuits are 15 volts and 5 volts, and that the one that I can read is, sorry, 620, then 1.2k is going to be, and that gives us 15. 1.2k is going to give us what? It's going to give us 7.5, which seems too high. But 1.8k would be about right. Let's set fire to a 1.8k resistor. See what happens with that. So before heating, 1.793. Okay, so next test, this guy here, 1.793k. And turn him on, thank you. Turn this guy on. So he's on, and then we'll turn the voltage up here. and hopefully we should be able to get a bit of smoke coming off. Fairly well. I probably didn't want it to catch fire. I'm not really sure that catching fire versus overheating, what the difference is. But anyway, let's find out. Whew. Come here, damn you. Oh, okay, this one's ended up open circuit, so that's no use to us. So I do have this situated over a heat-proof mat, of course. I've lost my crocodile clips, thank you. Okay, let's turn these guys on, let's turn this guy on, and just wind the wick up a little bit. Hopefully this time we won't actually catch fire, we'll just smoke a bit. So we're running about 50 milliamps, I'm not really getting any more smoke on it, which would tend to, I'm going to call it a day. Like that. So let's see what this came out at. I know it hasn't open circuited because, so 1.75, so it too has dropped a little bit. This one starts life at 1.79 exactly. I'm not on down here, that's better. Okay, so I'm straight in at 50 milliamps with this one, just turning up the shade, make sure I am at 50 milliamps. So this is reasonable burning. It's enough to destroy the colour code, but actually the resistor itself is not catching fire. So I think the resistance is decreasing despite the fact it's hot, and the reason for that is the current has actually just edged up a little bit all on its own. Fairly charred resistor. Okay. This is 1.79 before we started. It's now 1.52. Okay. Here it is, 680. Right, so I'm going to go at 30 volts, which is going to give me hopefully not too much current. So current 0.045, but the power is I squared R, so I need to, roughly speaking, double that. Whoa, 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 we're just going a bit fast there. And yeah, I'm going to go for that. I think that's not dissimilar from the one I took off the board. Look at its value. Actually, it's still a bit warm, but yeah, 0.60. So this is hardly scientific. I should have measured temperatures and all sorts of things, but it gives a good starting point. So first of all, 1.2k, medium charred, and that turned into a 1.1k resistor. Now that's interesting because that's pretty much the value I'm reading of the charred resistor from the board, but the one from the board is heavily, I mean, you know, it is just carbon. So yeah, I don't think that that's necessarily representative. The 1.8k caught fire, that just became open circuit, so that's simple, we can just ignore that for my purposes. 1.8k with light charring just reduced a little bit, medium charring reduced to 1.5k, so I think we can say with heavy charring it would have probably got down to about 1.1k-ish. Turning to the other resistor, which seemed to have a blue stripe on it, which would indicate it's in the 600 region. So this is, first of all, this is a risky assumption, because as we saw, our blue stripe actually turned green in our experiment, but pigments vary from manufacturer to manufacturer, so who knows what happened on this board. But anyway, the first one was a 680. We caught it on fire and it turned into 6K, so that's pretty useless. The other one was 680, and we did some sort of low to medium charring on this. It sounds like I'm cooking steak rather than burning resistors, but anyway, low to medium charring gave 602 ohms. Now that is pretty consistent with the 610 ohms that I'm kind of measuring the resistor at, and the charring is similar, so I think that's probably a bit of a goer. So what am I going to do in terms of the actual circuit? Well, so yep, so the one I measured at 610 is medium charred, so I'm assuming we started at 680. Now the other resistor, this is a bit of a conundrum because it's a lot worse. It's charred beyond recognition. Now normally I would say that would indicate it was a lower value because I've only got a certain amount of voltage available, and the voltage across the lower resistor would have more current and therefore heat more. So my first inclination is that should be a lower value than the 610, but maybe a 220 or something like that. So we've got roughly a 1:3 ratio between them because we've got a 1:3 ratio on our outputs, I believe. I think it's going to have a 15 volt and a 5 volt outputs. So did it increase actually because it caught fire? And we saw that very clearly earlier, how something multiplied in value by 5 just by catching fire. Yeah, or it could be a 1.8K and it's reduced to 1.1 because it's really heavily charred. So what am I going to try in my power supply circuit? Well, I'm going to try the 680 because that feels pretty good. It looks very likely. Everything's consistent on that value. So that will be my kind of starting reference point. Now I'm going to try the 1.8K next. And that's because it's a high value, and therefore, should there be a problem, we'll actually get lower current than we should have through it. So that's kind of probably a safer bet. It's safer to go with too little current, generally speaking, than bunging, let's say, a 220 ohm resistor and then finding that it's 6 times more current than it should have. So, or even more than 9 times more current than it should have. So, yeah, so that's the way I'm going to go, I think. Now, I don't have these in 2 or 4 watt, so 2 or 3 watt packages, which I think what was on the board was a 2 watt. So I'm going to kind of take 4 680s and I'll put 2 in parallel, and then I'll put another 2 parallel in series with it to make an array of 4. Now my resistors are 600 milliwatts, so that'll give me 2.4 watt resistors thereabouts, and I'll test it with that. And when I get the values right, then I'll go and buy the actual proper resistors, and I'll buy them in flame-proof coatings and all of that sort of stuff. So anyway, I think that's about it. I'm hopeful that someone else might pick up from where I left off and do some more comprehensive, more scientific measurements and share those with us. But hopefully you liked this video. If you did, please give it a thumbs up and all that sort of thing. And of course, leave some comments down below. And of course, if you haven't already done so, please subscribe. I'll see you next time. Take care.